Welcome to this course on working with Llama. In this video, we will review the key properties of Llama 3 and describe its training process. Llama 3 is an open source large language model, or LLM. It was built by Meta, but the license allows anyone to use it. Llama 3 has a large token vocabulary of over 120,000 tokens and can process input sequences of over 8,000 tokens. Llama has models with different parameter sizes, including 7 billion and 70 billion parameters. A model's parameter size determines how much information the model can hold. There are general-purpose versions of the models at each parameter size, and instruct versions, which are further trained with special conversation data for chat applications. Llama 3 was trained on trillions of words from books and websites, with data spanning 30 different languages. That's equivalent to 15 million copies of the Harry Potter books. It took 24,000 GPUs to pre-train the model. Llama used 4 training techniques: supervised fine-tuning, which trains on data labeled with a specific objective; rejection sampling, which filters out text samples lacking qualities like fluency or relevance; proximal policy optimization, which uses a separate model to figure out high-quality data examples to train the model with; and direct preference optimization, DPO, where human evaluators compare and rank generated text samples to help them train the model to produce higher quality results. We can use Llama 3 locally via the Llama CPP Python library, a Python binding that enables the use of a C++ implementation of Llama called llama.cpp. The Llama class in the library lets us adjust various settings of the model and interact with it. The Llama CPP Python binding acts as a bridge from the original C++ code to the Llama class. To start, load the Llama class from the package and instantiate it using the path to the model saved in gguf format. This efficient file type is popular for loading and storing models in inference tasks and will be used throughout the course. We can call the model with your prompt to get a reply and other metadata in a dictionary, with the reply stored in choices. The output is stored in a dictionary with key value pairs for metadata. Our output text is under choices as a list of dictionaries with additional metadata. Access the text via the text key in the first element of choices. Let's use Llama CPP Python to ask Llama 3 a more rigorous question. We load the library and model and set n GPU layers to -1 to load the model to GPUs. In the completion call, we specify the max tokens to limit the number of tokens, and stop tokens, which stop generation when these tokens are generated so the model doesn't ramble. Then we parse the output to get the result. That's a lot of species.